Okay, so let's take everything we've learned so far and graph some quadratic functions. So, but this time we're going to use calculus the entire way. We're not going to look for symmetric points or any of that. We're just going to use the calculus knowledge that we've gained in the last couple videos. So let's assume we have a function f of x equals 4x squared plus x minus 1. Okay, so first thing we want to do is go straight to our first derivative. That gives us 8x plus 1. Second thing we need to do is take the second derivative, which is 8. So 8 is greater than 0, so this function is concave up. Okay? Now, let's go ahead and break out our Cartesian coordinate system. Okay? This function is concave up. Okay, and because there's no variable with that, the concavity doesn't vary at all as a function of x. What does this mean? It's concave up for all x. If that's the case, then we must have a minimum somewhere. In order to find the minimum, we're going to set our slope equal to 0. So 8x plus 1 equals 0. That means x equals negative 1/8. So that is our x coordinate of the minimum. Okay. Now to find the y coordinate of our minimum, we're going to plug this negative 1/8 back into the original function. So f of negative 1/8 equals 4 times negative 1/8 squared minus 1/8 minus 1. So this gives us 4 times 1/64 minus 1/8 minus 1. This gives us 4/64. Now, let's see. 4 divided by 64 is 0.0625. But let's go ahead and work this out in fractions first. Let's see. So that gives us 4 over 64 minus 1/8 minus 1. Let's go ahead and find a common denominator and work it out in fractions all the way through. So that equals 4 minus, now 8 goes into 64 8 times, minus 8. And of course, 1 goes into 64 times. Divided by 64. Okay? So that gives us negative, that gives us 4 minus 8 is negative 4 minus 64 is negative 68/64. And this is approximately negative 1.062. Okay, so somewhere down here, negative 1.062, that is our minimum. Okay, so we know the function is going to come up on both sides from there. Question is, where? Okay, now we know where the y-intercept is, right? Because we can simply calculate f of 0, which equals negative 1. Okay, so this is negative 1.062. So right above this at negative 1 is our y-intercept. So we know this function's going to come up like this. And of course it's going to be symmetric, and it's going to come up like this on the other side. Okay, so now let's tighten this graph up a little bit, and let's get our two x coordinates, our two x-axis intercepts. How do we do that? Well, you remember way back when we're going to set that equal to 0 and break out the quadratic formula. So the quadratic formula will give us x equals -1 plus or minus the square root of 1 squared, which is 1, minus 4 times a times c, all divided by 2a. Excuse me, 2 times 4, 2a. So this gives us -1 plus or minus the square root of, let's see, that is 16 plus 1, square root of 17, divided by 8. So this means x equals, let's see, -1 plus square root of 17 equals, divided by 8 equals 0.39, or x equals -1 minus square root of 17 equals, divided by 8 equals -0.64. Okay, so right here at 0.39, that is our one x-intercept. Our other x-intercept is at -0.64. Okay, and we've just graphed a quadratic function. Let's do another one. So assume we have f of x equals x squared plus x plus, or excuse me, let me make that a minus 2. Okay, so again, go straight to our first derivative. It's f prime of x equals 2x plus 1. Second derivative is 2. It's 2 for all x, meaning it's fully concave up and it's going to have a minimum. Again, how do we find the minimum? Set the slope equal to 0. So 2x plus 1 equals 0, means x equals -1/2. Okay, so let's again break out our Cartesian coordinate system. And at x equals -1/2, that is going to be where our minimum is. We need to find the y-coordinate of that minimum, so we're going to find f of -1/2, which equals -1/2 squared minus 1/2 minus 2, and this equals 1/4 minus 2/4 minus 8/4. Okay, just finding a common denominator as we go just makes it a little bit easier. So this equals -1/4 minus 8/4, which equals -9/4. Okay, and -9/4 is what, 2 1/4? -2 1/4. So somewhere down here, -2 1/4. We're going to have our minimum. Do we have a y-intercept? Of course we do, and that is at -2, because we can find that by finding f of 0. Okay, so at -2, okay, that's going to be our y-intercept, and so our function is going to come up like this. Now, what are our x-intercepts? Well, we're going to set this equal to 0 and use the quadratic formula. This quadratic formula would say x equals -1 plus or minus the square root of 1 squared minus 4 times a times c, all divided by 2a. So x equals -1 plus or minus the square root of, let's see, 9 divided by 2. So this is easy. So x equals -1 plus 3 divided by 2, which equals 2 divided by 2, which equals 1. Or x equals -1 minus 3 divided by 2, which equals -4 divided by 2, which equals -2. So over here at -2 is one intercept. Over here at at +1 is the other intercept. Okay, and we've graphed another quadratic function. Let's do another one. Let's do a very similar function. F of x equals -x squared plus x plus 2. So it's very similar to the last one, just flipped a couple signs really. First derivative equals -2x plus 1. Second derivative is -2. Now that's negative for all x, therefore it's concave down. Okay, meaning it's going to have a maximum. We find the maximum by setting the slope equal to 0. -2x plus 1 equals 0. This means that x equals 1/2. Okay, so breaking out our Cartesian coordinate system, we get x, y, x equal to 1/2. That is the x coordinate of our maximum, because this is again concave down, so it's going to have a maximum. Find the y coordinate by plugging this back into the original function. So that is f of 1/2, which equals -1/4 plus 1/2 plus 2, which equals -1/4 minus 2/4, plus 2/4 plus 8/4, which equals 1/4, which equals 9/4, about 2 1/4. So somewhere up here is 9/4. That's going to be our maximum. Now we have a y-intercept by solving for f of 0, which equals 2. So right about here at 2 is going to be where our y-intercept is. So this function is going to come down like this. Let me get rid of this and extend this out a little bit. What are our x coordinates? Well, we're going to take this, put it through the quadratic formula. That gives us x equals -1 plus or minus the square root of 1 squared minus 4 times a, which is -1, times c, which is 2, all divided by -2. So this gives us x equal to -1. Let's see, that's 9 again. 1 plus 3 divided by -2, or x equals -1 minus 3 divided by -2. This would be 2 divided by -2, which is -1. This would be -4 divided by -2, which is 2. So as you can see, it's basically the same function, just kind of flipped upside down a little bit and moved a notch. Okay, so that is another quadratic function. Let's do another one.